Ask My Instructor 9.3.34. Evaluate the geometric series or state that it diverges. The geometric series converges if the ratio r has a magnitude less than 1. And if the series converges, there's a nice formula for finding what it converges to. What fixes do we need to make to have our series fit the series of the formula? Well, we need to have a series that starts at n equals 0. And we need to have a series where the exponent is n. We will work on that issue first. First, I use the power to a power rule. Then 2 over 7 to the third power is just 8 over 343. So now my series is written with an exponent of n. Next, I work on rewriting the series so that it starts at n equals 0. Again, let's start with an observation. Okay, but how does this help us? Notice that the very first exponent of this series, the very first exponent is 0. By pulling out that 8 over 343 squared, by pulling that out, I now have a series where my exponents is 0 first, and then 1, and then 2, and then 3. So we can rewrite the series to reflect the fact that the first exponent is 0. So we can now use the formula for a geometric series because we've got our series starting at 0 and our ratio is to the n power. So we can rewrite or we can use this formula where a equals 8 over 343 squared and r, the ratio, is 8 over 343. Now, we can only use this formula if the magnitude of the ratio is less than 1. But that's pretty obvious that the magnitude of r is less than 1. 8 over 343, that is less than 1. So we can use this formula. So just plug everything in. A is equal to 8 over 343 squared. R is equal to 8 over 343. Okay, but this is going to require a little bit of cleanup. I need to simplify this. So first I bring my 8 over 343 squared. I just bring it out to the front. And then I rewrite the complex quotient by multiplying the numerator and the denominator by 343. And then I do the subtraction. And then a little bit of cancellation. I have 343 in the numerator and I have 343 squared in the denominator. And then I just go ahead and multiply 64 times 1 and multiply 343 times 335. So we started with this series. We wrote it with an exponent of n, rewrote it again so that my n starts at 0, used the formula because our ratio was less than 1, and then cleaned it up. Take care. Have a nice day.